Hi folks, and welcome back to Math with Captain Rod. I'm making this video here to answer the question that I know is just on everyone's mind. When does a rational function have a horizontal asymptote? And if it does, how do you find it? So rational functions are functions that can be written in this form. I wrote p of x over q of x, where the p and q are both polynomials. I've got a bunch of examples on the left. And to tell whether they have horizontal asymptotes or not, you look at these powers, or you look at these polynomials, and you look at the highest power. So let's say that the highest power on this polynomial is n, and the highest power on q is m. If these are of the same power, that means that long term the function will converge to some constant, and you'll see examples of that here in a minute. If n is equal to m, you will get a horizontal asymptote. I'll just put yes on horizontal asymptote, and we'll see examples how to find it in a minute. If m is bigger than n, like for example it's second power up top but third power in the bottom, that means that this will get larger faster than this, and y equals 0 will be your horizontal asymptote. All right, so let's take a look at a bunch of examples here. We're going to look at these examples on the left. So we're going to take a look at this first one right here, y equals 3x over x minus 1. Now notice that the power up here is 3x to the first power. Power on the bottom is x to the first power. So this function, when x gets really big, is going to level off to some constant. So as far as finding that constant, I'm going to do a little mathematical trick here. If you multiply the top of this by 1 over x and the bottom by 1 over x, the top is going to become a 3. The bottom, this product, is going to be 1 minus 1 over x. And when x gets very large, we say when x goes to infinity, 1 over x goes to 0. So this becomes a 0. And then y is going to 3. And there is the equation for your horizontal asymptote. And what that means is, if you sketch this graph, now in this region here there's a bunch of detail, but I know that eventually this thing has to converge over here to y equals 3 in this direction and this direction. Okay, and I'll talk about how you get the detail work in another video. All right, let's take a look at this one right here. So in this example, the top is first order there and the bottom is second. So the bottom's going to get bigger faster than the denominator here. So what's going to happen? The horizontal asymptote is y equals 0. You can do the same trick, by the way, as I just did here. Divide everything, like multiply this by 1 over x. Actually, you would do 1 over x squared and 1 over x squared. You typically do the highest power of x that you see. Notice that you'll have 4 over x up top here, and when x gets large, that becomes a 0. In the bottom, you'll have 1 minus 1 over x squared, which, when x gets large, that becomes a 1. All right, let's take a look at this one now. Here, the top is second order and the bottom is first. So this thing's not going to have a horizontal asymptote. This one's going to have a linear asymptote, or what we call slanters. This will have a slanting asymptote. Anytime the top is exactly 1 power higher than the bottom, that means the function will approach a line when x gets really large. And I'll make another video on how to find those. The purpose of this video is just finding the horizontals. We're going to take a look at this one right here. Okay, first order up top, second order in the bottom. I'm going to go ahead and use that little trick here. If you take this 4x over x squared plus 1 and we multiply the top by 1 over x squared and the bottom by 1 over x squared, you get 4 over x in the numerator, 1 plus 1 over x squared in the denominator. And when x gets large, in math we say when x goes to infinity, 4 over x, this goes to 0. That becomes a 0. This goes to 0, but the bottom goes to 1. So the whole darn kit and caboodle is going to 0. So y equals 0 is your horizontal asymptote. Last but not least, let's take a look at this one. Top is second order, bottom second order. Going to use the same little trick on this. Multiply the top by 1 over x squared, the bottom by 1 over x squared. Okay, so this is equal to 1 over, and when we multiply this out, we get 1 plus 1 over x minus 6 over x squared. And for large values of x, right, this is becoming a 0, and so is this, so both of these are becoming 0. We're just going to put approximately 0, and we're left with just 1. So y equals 1 is our horizontal asymptote for this rational function. So anyway, the video here was a little bit about how do you know when you have one. Right, you're going to have one anytime when you're looking at a polynomial, the top and the bottom have the same power, or whenever the bottom has a higher power than the top, like here, then the function will have y equals 0 as a horizontal asymptote. So hope this video has helped. Have a great day.